So it's my great honor to introduce our speaker today. He was supposed to be here in person on campus, but unfortunately he had some unforeseen event that led to him having to present on Zoom. So our speaker today is Timothy Setchinger, who is a research scholar at the Princeton School of Public and International Affairs and the Center for Policy and Research on Energy and the Environment at Princeton University. Trained as a lawyer, his work combines ecology, agronomy, and economics to analyze the challenge of how to feed a growing world population while reducing the environmental consequences of agriculture, particularly land use, which is going to be talking about to us today, greenhouse emissions and nitrogen pollution. He's the author of a series of 5 papers in Science and Nature. I encourage you to check them out. That are, calculating the greenhouse consequences of devoting land to bioenergy and food production. He's the lead author of a comprehensive report for the World Resources Institute, the World Bank, and the United Nations on how to meet global feed needs by 2050 while reducing greenhouse emissions. He's going to be talking to us today on a very topical title, that's entitled, "What is the carbon cost of using land?" And Tim, I'll hand you over. We're all here listening. Let's give him a cordial round of welcome. Over to you, Tim.
Great. Well, thank you very much. And I'm very sorry I'm not there. I had some back problems that unfortunately kept me from coming up. And I appreciate everyone showing up the morning after, obviously, a fateful event. But anyway, the show must go on. So my talk today is about how do we incorporate into our analysis of the effects on climate change of using land. As I'll talk about, the humans have a gigantic footprint on the land, which has caused huge amounts of carbon loss. And how we think about that, how we evaluate the consequences of that, has huge policy implications. So it is a key factor in life cycle calculations of agricultural products. That's the same method that companies use, basically a life cycle calculation to estimate their own emissions from their food production. Many companies have pledged to reduce emissions. How they count them, therefore, matters. There are a whole lot of laws that basically build in the effect on land in one way or another, or don't. This includes biofuel mandates. There are emissions trading systems, which essentially treat the emissions from burning biomass as free, as neutral, which I'll explain is really a way of not counting the cost of using land. There's subsidies for all kinds of agricultural activities designed for climate or for energy that have implications for land. How it's factored in matters. Offsets, people want to restore land, restore some agricultural land to forests. That causes leakage to replace the crops. How they count that, therefore offsets, how they count the use of land is critical. And even in national emissions, so national countries count their emissions, and then they adopt policies to reduce those emissions. And again, how they factor in the cost of using land is critical to the policies they adopt for agriculture, energy, forests, many other uses. And I'll give you the headline right away, which is, in most of these methods, they, in one way or another, assume that using existing agricultural land is free. And because land is a very valuable, precious commodity, it's not free. And we're going to talk about how it should be calculated and what the implications of that are. So let me start with simply what's happening to global emissions from agriculture. About a quarter of the carbon in the atmosphere already is due to land use change, primarily for agriculture. Agriculture occupies about half of the world's vegetated land, and it's continuing to expand. This is a good satellite study, and what you see is just cropland, annual cropland, and the expansion of agriculture is shown over a 10-year period, or there's a 19-year period here in red. And basically, it's expanding at a rate of about 10 million hectares per year. And that's roughly equal to all the farmland in Iowa, almost equal to the size of England. There's another 1 million hectares. And remember, a hectare is about 2.5 acres. so basically, if we keep on this pace, we will clear an area the size of India in the next 30 years. And the problem is we need a lot more of everything land produces because of growing populations and increasing wealth. Typical estimates over a 40-year period are something like 50% more crops. You can see the amount of livestock products, also more wood, and even more urban land. So we have a global land squeeze, is the way we've phrased it. And even beyond cropland expansion, we're also clearing lots of forests for pasture, for cattle. We don't really know the net effect on pasture area because satellites can't really study it. FAO data is not very good, but it's the largest source of direct forest loss. This is what you see here. And a lot of this is driven by this relentless growing demand for meat, and you can see it expanding. That's why we're pretty confident it's going to keep growing. Most of the people in the world eat a lot less meat than Westerners do. And as they get maybe a quarter of the meat consumption of Westerners, meat and milk. And as they get a little bit wealthier and they even eat half of the meat and milk, it has this enormous increase in demand for land because it's very land intensive. And you can see this. This is causing greenhouse gas emissions through land expansion. About 10% of annual greenhouse gas emissions is counted, probably an underestimate for reasons I'll talk about, comes from agricultural expansion. Here you see oil palm expansion for vegetable oil in Indonesia. We have cattle expansion in the Amazon. This clears forests and other lands. You lose carbon that was stored in the forest and in the soils. And if this isn't enough of a challenge, a lot of climate solutions, so every climate solution pretty much assumes no additional land use change going forward. So as I said, we're on pace to clear at least 300 million more hectares. They say no, but most climate strategies also assume that we're going to reforest a bunch of land, these known as natural climate solutions. Now, where's that land supposed to come from if we're still expanding land? And almost all models predict continued expansion, consistent with what's actually going on. And the thing about these models is some are a little bit of land, some are a lot of land, but they already build in large yield gains. So we, in this report called Creating a Sustainable Food Future for the World Bank and the UN and WRI, we did a modeling study. We said, well, what would happen to the world's land use if we tried to produce all the food that's likely required in 2050 with today's farms at today's yields? And the answer was we would clear an area more than 3 billion hectares of land. That's about 4 times the size of the continental United States. So even with historic yield gain rates, which are hard to achieve, we'd clear an area roughly 2 sizes the size of India, including both pasture and cropland. So this means, so what's the lesson from this? Well, if you need more food and more carbon storage, not less, but we have a fixed land area, right? We don't create more land, as has been said. They ain't making land no more. They ain't making no more of that land, according to Mark Twain. He was right. It means the only way we can hope to solve climate change, let alone avoid adverse impacts on biodiversity, is by increasing land use efficiency. And that is both in the way we consuming products that require less land, and we have to produce more food on the same existing agricultural land area. And another implication is land is valuable stuff, right? It ain't free. We've only got so much of it. Okay, so what's the typical approach to evaluating the carbon cost of land? So here, one of the big things that's happening is expansion of soybeans. Soybeans are one of the 2 main sources of vegetable oil, which has been growing enormously, both due to food demand and biofuels. And they're a big source of protein feed, basically chickens. You can think of chickens as walking around, or slightly walking around soybean meal. And the basic approach is to say the only time we're going to count an emission from using land is if the product, the soybeans that we buy, are purchased on, are made on recently deforested land. It's known as direct land use change. So what that would mean is that If you get your soybeans from Iowa, where the land was cleared 100 years ago, more than 100 years ago, there is no climate cost. If you get your land from a newly cleared area in Brazil, Mato Grosso, it has a climate cost. Now, there's a version of this called statistical land use change, which says, well, we don't necessarily know where the soybean comes from in Brazil, so we're going to assign some emissions to every soybean on the theory that it contributes to land expansion in Brazil. And the way it works is you have this kind of total agricultural land area in Brazil, you have a certain amount of deforestation, and the way it works is you basically say the land use change emissions are equal to the emissions from this deforestation, but divided by the total national crop production. So not just the amount of crops that go here, but the total national crop production. And the result is a very low number. And again, one of the effects of this is if you're in getting your soybeans from Brazil, that's bad, but you're getting your soybeans from the US, let's say that's good. And if you think about this, these are criteria that look at where stuff is grown, but not how much. And what that means is if you're, let's say, a European livestock producer, you want to reduce your emissions, you just buy soybeans from the US. And you say, I've reduced my emissions. I'm not getting them from Brazil. And another way of thinking about it is this. If you just use existing agricultural land, no matter how much, it's free. You can double your use of existing agricultural land. There's no climate cost. You could cut it in half by being more efficient in your diet or in your production. There's no recognized climate benefit. Existing agricultural land is free. Now, I'm going to jump a little bit ahead to say one reason this is kind of, in my view, nonsense on stilts is that global crop prices transmit globally almost instantly. So this is true even for different vegetable oils. So here's, I got this literally off the web, although there are rigorous studies that show the same thing. And basically what you see here is that the price of soybean oil in the US and the price of palm oil in Malaysia pretty much track each other. They're different vegetable oils, they're in different places, but there's enough substitution that basically they're one product, or they substitute as one product. And what that means is that if you increase demand anywhere in the world, which increases the price, that price will be transmitted to precisely where you can have a lot of land use change, such as in the tropics, where it's cheapest and easiest. So it doesn't matter where your stuff comes from, you're transmitting a price increase to expand basically where vegetable oil comes from, which is primarily oil palm expansion in Southeast Asia and soybean expansion in the Amazon, Latin America. And you can even see this, though, in the US, our biodiesel consumption went up and mostly used, in theory, domestic vegetable oil, but we basically just imported more vegetable oil as a result. They basically track each other here. So let me show you another way in which land is treated as free. So this is in the life cycle calculations for biofuels, and it looks complicated, so I'll explain it. Here's the emissions from gasoline, and here are the emissions from ethanol. And a life cycle calculation tries to compare the emissions in all stages of production. So this is the emissions from mining crude oil. They're not that high. That's not the cost for using gasoline. But the cost of producing grain is pretty high. You fertilizer, tractor fuel. So there's quite a lot of emissions. This is per megajoule of fuel, same quantity of fuel. The emissions from refining crude oil into gasoline aren't very high, but they're a lot higher for refining grain into ethanol. Now, the carbon that's actually emitted out of the tailpipe of the car is exactly the same. And on top of that, when you refine a starch into ethanol, about a third of the carbon, not about, exactly a third of the carbon goes off into the atmosphere. So that's this amount of carbon. And basically, actually, I think that should be 36.5 now I'm realizing it. And if you added up all those emissions, they're almost double the emissions from producing gasoline. So if you just counted the actual physical carbon that's emitted in the process, ethanol emissions would double those of gasoline. But the typical rule is we will not count these emissions. The theory is that growing the plants, growing the crops, absorbs carbon, and it cancels out the carbon emitted by burning the crop. And if you don't count this carbon, you can then get a greenhouse gas reduction. So the thing I want you to think about is it takes land to grow plants. This is saying we're going to claim a benefit from growing plants on land. That's the benefit for biofuels. But what's the cost? Where's the cost of using land? The answer is there's no cost. So this typical formulation also treats land as free. Now, the last common way of doing this is to use an economic model. And the economic model tries to predict what happens if you increase demand in one place and what happens to land use change all around the world. It's not just expansion that could occur. People could consume less food. It's possible farmers could intensify their production. There are these global land use models that try to estimate what is known as leakage or indirect land use change, and I've done that in the past myself. But I think that is the wrong approach, not only because I'll explain you can't, those models don't have any real validity, but also because they're doing the wrong thing. So here's one way to think about it. How do we estimate the emissions of using coal or the emissions of using natural gas? The short answer is we just look at the amount of carbon that's released, right? How much carbon is going up here? How much carbon is going up there? Now, what if you instead tried to use an economic model to say, what would happen if we produced less coal? Well, if all you did was just produce less coal, that economic model would probably predict that people would just switch to natural gas. So in that case, you'd say, well, look, the coal emission, if you use that to say what are the emissions of coal, then only about 40% of the emissions of coal, or only 60%, only 40% of the emissions of coal would count. And similarly, if you use the model to look at natural gas, and say, what if we produce less natural gas? You discover, well, the economic model says you switch to coal and emissions would go up. And you might say, on that basis, natural gas has negative emissions. But that's not how we evaluate them. That's the way you analyze a policy question, not what are the emissions of each. And it's a different question. And another way to think about this, so basically an economic model is looking at what is the effect of a specific policy. So if all you did was say, don't produce coal, but you can switch to natural gas, you're not going to get that much savings. But if you just replace coal instead with, let's say, solar, you get a huge savings. What savings? The answer is we'd save all the carbon emitted by coal. So what we really want to know with biofuels or with land is what's the cost of using that land? So for emissions, what you do is you compare the cost of one human activity with no human activity, not the alternative human activity. Now, let me give you another example of this. Imagine you applied a model to say, what if we basically reduce the number of large cars available? The model would say, well, maybe emissions would only go down by half because you drive small cars. And if you applied the model to small cars, it'd say, well, the emissions would double because you drive large cars. So small cars have negative emissions. And in that case, if you drove 50-50, you conclude that driving causes no emissions at all. So the point is we shouldn't be using economic models. Now, on top of that, and I won't spend a lot of time on this, these economic models lack almost all of the actual economic parameters. So I've just done a paper with Steve Barry, a very prominent economist at Yale, evaluating the GTAP model, and it has literally thousands of economic parameters. And essentially only even a tiny number of them are claimed to have any empirical basis at all. But in fact, none have an empirical basis. And the reason is this. Well, I'll do this quickly because I want to go into other things. But essentially what the model does is it tries to evaluate, it assumes that when you switch when the price of one thing goes up, you switch to other things based on the share of the cost or the expenditure. So imagine you're making a cake and you have all these ingredients. And if you, let's say, increase the price of baking powder, the model, the equivalent of the GFAP model would estimate, well, what happens? How much less baking powder would you consume? And how much more of other things would you consume? Well, in the real world, we know that the answer is you probably wouldn't reduce your baking powder at all. Why? Because it has a particular function that these other things don't do. And at the same time, it's also cheap, right? But under the GTAP model, if you applied it, you basically would reduce that based on its revenue share. So if it's actually a small part of the share, you reduce that a lot. It also would estimate that you would substitute a little bit of each of these other products, even like salt or sprinkles for baking powder, based on their expenditure share. Well, as you can tell from baking a cake, that's not the way substitution works, and that's true of everything else. So basically, we concluded that literally every economic parameter in the model is made up. And in fact, there are also other issues, which is it doesn't even evaluate land, it evaluates revenues. And we discovered that, for example, for a biofuel analysis for California, it actually estimated that to produce 1.5 million hectares of cropland, you'd actually have to lose 17.3 million hectares of forest and pasture. Well, that's obviously numerically not possible. So then they just cut that by 90%. And any model that produces an absurd result and then you artificially readjust after the fact is got no validity. So the reason for this, though, the reason that for all of this stuff is that the actual thousands of economic parameters you would need to program the model for an empirical basis don't exist. So practicality too. Okay, so now the question is, how should we evaluate land? So what's the value, the climate value of Iowa cropland? Well, I would submit that one of its big values is to produce food. In a world that needs more food, and we want to avoid clearing more land, probably the highest value of Iowa cropland is to produce food. If you need more food, would it be a good idea for the climate to basically take out of production the world's most productive cropland? Probably not. So the value of producing food there is allows other land to store carbon. Now, even if you just concluded that you didn't need the farmland for some reason, well, you could grow a forest and you could sequester carbon in a forest. And now that they don't have fire anymore, that's exactly what you'd get. So that could be an alternative too. Another carbon cost of not using that land, let's say, for biofuels rather than food production. And according to economics, the value of that land is the highest alternative use. That's known as the opportunity cost. And that is the way we assign a cost or a value to absolutely everything. What is the highest alternative use value? And that would be true of finance and of climate. What is the highest alternative climate use of the land? So if you really didn't need it to produce food, you could produce a forest. No, that's the cost if you don't use it for that purpose. So we had a paper in Nature in 2018 where we said, okay, let's try to measure this in a very basic way. And another way to think about this is, well, if you want to look at the emissions of making a car, to make a car, you need to make a car factory. And if the emissions of making a car factory are large, you have to assign a little bit of the emissions of each factory to each car. Well, to make crops, you have to stop by making cropland. So by the same principle, we should assign a little bit of the cost of making cropland to each crop. And the way we measure it is by individual crop type and livestock type. So here, for example, for corn, here is the amount of carbon that would be stored. This is our estimated amount of carbon that would be stored on land everywhere in the world. And here is the land that's used for corn. And you basically come up with an estimated carbon loss for each acre, each hectare of land used for corn. And from that, you can ultimately derive a carbon loss per ton of corn on a global basis. And so the number is pretty simple. It's the carbon loss from land used to produce a product like corn divided by the yield. That's it. Well, that gives you an absolute number. And then the question is, well, we can produce crops for a long time. So we have to kind of annualize that. We did it by using different discount rates, 4% being our major one. You could just divide by 20 or 30 years. Why would you do that? The reason you do that is a policy judgment that we particularly care is particularly valuable to reduce carbon in the atmosphere over the next 20 or 30 years while we're trying to hold down climate change before it gets away from us before we can actually do enough about it. So it's a policy judgment how much to focus on that. But for example, in biofuels, governments have generally agreed to use 20 or 30 years to kind of look at the balance of emissions over that. So if we need another hectare of land to produce more corn, we divide the cost of that, the carbon loss by 20 or 30 years. And for meat or milk, it's simply basically the same thing. It's the carbon cost of all the feeds and pasture divided by the production of milk and meat. And then you use an allocation method to allocate. If you're, let's say, using cows that produce both milk and meat, you have to allocate those emissions. Now, when you do that, you get some interesting findings. And I'm going to focus, there are different columns here. These are the carbon opportunity costs. This is the land use cost. We call it the carbon opportunity cost. And these are the emissions from the production. So this is in kilograms of CO2 equivalent per kilogram of fresh weight. That's the same as tons for tons. And first of all, what you see is that the land use cost is much higher than the production emissions. We tend to focus only on the production emissions, like the methane or the fertilizer emissions, things like that. But the land use cost is much higher. And the second thing you see is a huge change, huge difference. So for corn, maize, it's 2.1 tons of carbon per ton of maize. Now, interestingly, for soybeans, it's about 6 tons. Why is that? Well, even though they use the same type of land, soybean yields are a lot lower than maize yields. And so for each ton of soybeans, you lose more carbon. Now, look at the really interesting thing is beef, let's say, per calorie than maize or soybeans. It's wildly higher, and it's much higher than pork. And I think you can't see chicken here. I somehow cut that off. And milk too. And in fact, this basically tells you that to produce beef takes an enormous amount of land that loses an enormous amount of carbon. Separately, in the US diet, we've calculated that beef is about 45% of the carbon opportunity costs. It's only 3% of the calories. And that tells you that if you want to make progress, you have to do things with beef. Now, let me give you some examples of that. Actually, let me start right away with beef. I'll come back to the biofuels. So when you apply, this gives you an emission cost for consumption. And when we studied this, applied this for a meat-heavy European diet, two things were interesting. One is that the total carbon cost, including both land use costs, the carbon opportunity costs, and production emissions, was close to 9 tons per person per year. And that's interesting because that's a typical estimate of the carbon costs of all consumption by Europeans, not just food. And the reason is that what they've left out is the land use cost. And what this tells you is if somehow magically you could cut all these emissions, then over a 30-year period, you would save that amount of carbon. And you could see that the enormous savings you get in shifting to a vegan diet or even just shifting away from ruminant production. Now, conversely, this also means there's an enormous value to increasing the land use efficiency of beef production. So in Brazil, there's a lot of beef production. Most of it occurs on degraded land that's badly managed. You can manage this land more like this to get many times more production per acre. And we analyzed what would be the climate benefit of doing that. So let's say you have a a low degraded land like this, and you're only producing about 30 kilograms of beef per hectare, and you have a chance to improve it, so it's producing 200 kilograms, what's the relative benefit of that versus even turning that into ethanol or reforesting it? And it turns out the best thing you can do is that. Now, why is that? It's because that allows us to save that much carbon from converting more land to meet rising beef production in the world. So let me go back to biofuels. So for biofuels, we did the analysis, and it turns out that even after accounting for byproducts and all these other things that biofuels produce, the greenhouse gas emissions from the land, the carbon opportunity costs, are 3 to 4 times the actual savings from avoiding gasoline. And this is before even counting the production emissions. So if you were to think of this, those of you who study indirect land use change, as the typical cost of converting land to produce that much corn or soybeans to go into a megajoule of these fuels, it is going to be 3 to 4 times as a whole the emissions that you save from avoiding gasoline. And you can see this too when you look at the land use costs this way, where we production emissions and land use costs and compared it to gasoline or diesel, they're a lot lower. And then to solar power, which basically uses land 100 times more efficiently, at least, than ethanol. And actually, it's more like 300 times when you factor in the efficiency of an electric engine. Basically, your emissions, the land use cost is almost non-existent. And even with today's batteries, the emissions are a lot lower. Okay, so what are the consequences of treating land as free? So we have all kinds of strange views and policies. So one view, for example, in Europe, particularly, is we should just avoid using soybeans for our livestock product, and maybe switch to some other animal feed like that we produce in Europe, like faba beans or something like that. Well, you shouldn't blame the soybean. The reason soybeans are being produced, soybeans are a fantastic crop. They're extremely high yielding. They fix their own nitrogen. The problem is not the soybean. The problem is our growing global demand for meat. And if you try to feed meat with something other than soybeans, you'd actually need more land. So try to reduce your meat consumption, try to produce it more efficiently. But if you're going to be a feed, you want it to be soybeans. It's not a bad thing. And then similarly, you'll find people like opposed to helping Latin America to improve its beef production per hectare, even though when you it's desperately needed if we're going to provide the land necessary for growing more crops, or let alone reforestation and things like that. Now, another thing is that because they're treating land as free, Europe came out with a climate policy, and I had another paper in Nature about this, that basically contemplates taking 1/5 of its cropland and turning it into energy crops. That's what's in its model. And this is even though Europe today, basically, for every 4 acres of land it devotes to food production in Europe, it devotes 1 acre of land abroad. It's already basically a tax on global land. And the climate strategy was to take yet more, produce even less food, import more food, but call it a climate benefit. Another issue is there's this big push to make aviation fuel from vegetable oil. And there's a question of whether that would be subsidized. Again, as I showed you, the emissions using carbon opportunity costs are probably 4 times the savings, at least 4 times the savings from jet fuel. And if we were to try to produce 1/4 of global aviation fuel in 2050 from vegetable oil, it would require an additional 40% of the world's cropland. A tripling, basically, of vegetable oil production. And you can just see this just in the sheer most obvious efficiency terms. So as I was already explaining, that PV, solar power, basically generates into ethanol, even on good agricultural land, which is the best for biofuels, about 100 times more energy than biofuels. 1,000 watts of solar give you, this was even on a net basis, this is already older, this is probably up to 200 by now. Solar energy and electricity corn ethanol is about 1.5. And then you get a threefold greater savings. So you're really 300 to 1 when you turn it into an electric engine. So having said that, let me give you just a couple more reasons why we should use carbon opportunity costs. So what's the right question to ask about looking at the cost or benefit of using land? The right question to ask should be, what's the best use of land? We have a limited amount of land. What's its best use? This is the right question. Actually, that's the wrong question. I'm sorry, I put it the right. This is the right question. What is the most beneficial way to vote land? What an economic model is trying to do is say, I'm not going to look at all the ways of devoting land or resources. I'm just going to say, what if we devote land to biofuels or reforestation and other things happen? Not, what if I devote the same land and the same other resources in the most beneficial way? But if we want to solve climate change, you want to use land in its best way. So even though I think even this answer is it should be very expensive, we know that in the real world, increasing demand in the US transmits into prices everywhere in the world, leads to land expansion wherever it is cheapest, namely in the tropics. Even so, the real question we should be asking is, what's the best use of land? If we want to solve climate change, what's the best use of land? And it makes sense to say if it's good agricultural land, it should be producing food. Maybe if it's bad agricultural land, we can reforest it. In fact, when you reforest land, you also get a lot more greenhouse gas benefit for 50 years than using that land for bioenergy, for example. But let me give you my last kind of explanation of this. So this is a little more intellectual. Why do we have these greenhouse gas accounting rules? We have national accounting rules, we have life cycle accounting rules, we use those for companies. Why do we do that? So I think the answer is we do that because we don't have a perfect global carbon price. Now, a perfect global carbon price would mean that if you, everywhere, if somebody causes emissions, let's say burns oil, that person would have to pay, that company would have to pay 100, let's say the perfect price is $100 per ton. I'm just assuming that. It would have to pay $100 per ton for the emissions. And the same thing would be true if you clear forest. If you clear forest, you pay $100 per ton. This would be true of all emissions. It would also mean that if you allow forest to regrow, you'd receive $100 per ton. Now, if you had a perfect global carbon price, you wouldn't need any other carbon accounting. Why? Because the cost of everything you buy would already incorporate the carbon cost, right? So think about it if you're, let's say, planning to buy some beef. Well, if someone's going to clear land to produce beef, they're going to have to pay $100 per ton, so it's very expensive. If they reforest land that's producing beef, they get paid $100 per ton. In Latin America, that would probably equal about $1,500 per hectare per year, which is just orders of magnitude larger than the average revenue from producing beef. What would happen is lots of land would reforest until the price of beef rises enough to keep land in production. And basically, you wouldn't have to assign a carbon cost because beef would be really expensive. Now, that's the point. We wouldn't need any other accounting. And one of the results would be that using land for any purpose other than carbon storage would be really, really expensive. The cost of using land not to store carbon would be built into it. Now, that's another way of saying land is valued for its carbon opportunity cost. That would produce pretty much exactly the same or very similar number to what we've calculated. We've used an average that would use the marginal, but basically that's what the cost would be. Now, there are lots of reasons we can't have a perfect global carbon price. There are political reasons, there are lots of practical reasons, but if we want to improve greenhouse gas emissions, if we want to solve that problem, we want to use land in the same way we would use land if there were a perfect global carbon price. Now, the last thing I'm going to say is, look, the major objection to using carbon opportunity costs is that they're not new emissions, right? The land was already cleared for existing agricultural land. You keep using it, it doesn't appear to be new emissions. There's a real cost because if you use it for something else, then people have to clear more land. There's a cost because if you didn't use it, you could reforest it and that would absorb carbon, but they're not new emissions. And typically scientists and governments only count new emissions per year, not something you've missed. So I want to explain how it basically still is the right answer, even to answer that question. So imagine, the way I'll explain it this, imagine that companies set targets for reducing their carbon opportunity costs at the level necessary to avoid agricultural expansion. What if everybody did that? In other words, how do you reduce carbon opportunity costs? You can either do it by increasing yields or by shifting, let's say, the products you sell from beef to chicken or to plant burgers, something like that. You can become more efficient in both your choice of products and in the use of land. Now, it turns out that whether or not you meet that target or don't meet that target should equal greenhouse gas emissions from new land use change. So imagine the world needs 1% more food per year measured in carbon opportunity costs. If everybody's efficiency in the use of land increases by 1%, you'd have no net land use change. If it increases only 0.8%, well, you'd need more land and more carbon loss by 0.2%. Now, that may look like a small number, but that's actually a pretty big number because it's 0.2% of all existing carbon losses from all land that was converted into agriculture in the past. But conversely, if your efficiency increases more than 1%, then you are contributing to avoiding land use change. So in effect, carbon opportunity costs is a way of measuring anyone's contribution to new global land use change emissions through the amount of land that they use. And that's the key. We have to count the amount of land that people use. So let me just summarize. I'm going to skip that. This is the amount of plant growth the world is capable of producing using native plants. And humans have actually reduced that. And when you look at this map, it makes you realize that our ability to produce plants is basically a somewhat finite resource. We can do things better or worse, but basically we have certain physical capability. And that means that the global land use competition means that land has a high value. The methods that I've described of direct land use change, statistical land use change, treating emissions from biomass as carbon neutral, they treat land as free. The economic models that are being used to look at leakage and ILUC ask the wrong question and they lack support. But carbon opportunity costs treat land like any other fixed input, like a car factory, and they ask the right question. What is the best use of land? So if we use carbon opportunity costs, we will know whether or not we are making more or less climate efficient use of land. It would mean that we would properly value dietary choices that reduce land use requirements. We properly value improvements in agricultural yields, efficiency that reduce the land use requirements. And the changes in that actually do equal to the emissions from land use change. And here's just a whole bunch of reports that go into global land use competition. I'll leave that up for the moment. That's the end of my talk. The end of my talk, bottom line, land is not free. Thanks.
Thank you very much, Tim. I'll ask if you can, before we go to Q&A, we will have a few minutes for that. I want to ask Mario, if you're online, if you have some quick reflections. Mario is a colleague of Tim and he's also working in the same area. Are you online, Mario?
Yes, I am. Can you hear me?
We can hear you loud and clear. You have about 2 minutes if we don't have too much time. So thanks for joining in.
Tim, thanks a lot. Thanks for a very thoughtful presentation. I'm sure that you've left a lot of people thinking about this deeply. I completely agree with you that land is the key, the key thing that we really need to consider if we're thinking from a climate change perspective. And I really like your idea of implementing carbon opportunity cost. Now, land is also there for a range of reasons, and carbon opportunity cost would be one of the things to take into account. Obviously, farmers will have livelihoods that need to be taken into account, although the economic modeling that goes into some of these things, well, you can debate it ad nauseum, but certainly, the profitability of enterprises driving land choices would also need to be considered into account. It's putting this into the context of a broader of the broader agri-food system. Ultimately, people will have to eat and make money and do these other things. For me, the critical thing is also to see how do we need to go to implement something that is practical in this sphere. What would you think are what are the next steps in the accounting framework to implement it in in real life systems? Because also one of the things, a carbon opportunity cost might lead to, transitions in the way that we use land and so on. And in many parts of the world, those transitions are not really costed either. So, the cost of including the cost of the transition will be essential to ensure that, the accounting framework becomes something feasible for producers, etc. So I'm just wondering, from your perspective, what are the next steps to ensure that this gets implemented, or where do you see the biggest bottlenecks for this to be implemented?
So first off, from a practicality standpoint, it's actually remarkably easy in a way. You're basically just saying, if you increase yields, you decrease your carbon opportunity cost, basically proportionate to your increase in yields. And we have a number, you use a parameter. If you decrease yields, you're increasing your carbon opportunity costs, at least intensity. And similarly, if you change diets or things like that, you get benefits or costs related to that. So it's actually, in a way, pretty simple. There we have charts, we have numbers. You can basically just factor that in an arithmetic way to your calculation. Now, I could also totally agree with you that it's just one metric. What this is this tells you your land use cost. There are other kinds of costs. There are other kinds of benefits. And in theory, if you were maximizing benefits, you would look at this plus other costs and you build them all into one cost function. In the real world, people will also decide to care about other things. So it's just this is the way we should have factored in land. There are obviously other things that people think about. Now, having said that, I would also say that the overwhelming lesson you would use, or the overwhelming difference in human behavior you would have if people took this seriously, would be that you would really value yield improvement. You'd really value anything that reduces the demand for land by being more efficient in its consumption. So at WRI, we've kind of coined the phrase that the solution to the world's land challenges is produce, protect, reduce, and restore. Produce more food on the same land, use that to protect habitat, reduce the demand for land-intensive products, and restore where you really are making inefficient use of land and can't use it for food. So that would be, I think, the basic behavioral changes that would occur if people responded to this. And one thing you wouldn't do.
Thanks,
I-
Tim. We have a few more questions. I want to make sure that we give a
Sure.
few more questions from online audience, just
Sure.
quickly, because we're going to run up of our time. Can you go ahead, Angeline, and read some of them?
Yes. We had a question from Daniel Lee. Keeping agronomical practices aside, obviously different crops will have different land use efficiencies or water use efficiencies in terms of calories and nutrition requirement by humans. Can we have a model or something to decide what crops and at what portion of them is best for a certain area of land?
And the answer is yes. So think about it this way, that one thing we think is important is to separate consumption decisions from production decisions. Any one producer can't really dramatically affect consumption decisions. So a consumer needs protein, needs all kinds of things. And because foods have different land use requirements, you can make more efficient, you can aim for a more efficient diet or more efficient consumption, reduce your food loss and waste, whatever. So in a sense, this gives you information about, given your different nutritional needs, what choices you might make. But a producer says, look, I can't really decide that. All I can do is produce more efficiently. So that's why it's really important. Like people ask me, what should a American beef producer do? And the answer is produce beef because and they're efficient producers and they should try to produce it even more efficiently. So I think that basically this does factor that in. In the real world, people are going to consume beef, and therefore it's important if people are going to consume beef for producers to produce it efficiently.
Tim, unfortunately, we've come up to our time, and there was a few more questions online, but those can be sent to us and we can forward them to you. I want to thank you for your excellent presentation and also for your, Mario, you were going to say something quickly?
Yeah, I think that there's a fundamental question that David Lee asked that I would like to hear Tim's response for. Is
All right,
David
those that need to
online
go to class,
still?
you can actually go out, but go ahead, Mario. Yeah.
Yeah, is David online so that he can ask it?
Yes. David Lee, are you online? Do you want to ask your question?
I think maybe some people can't speak. I think they can only.
Okay,
Yeah,
so
muted, right?
I'll ask it on his behalf.
Yeah, can you go ahead, Mario, and
So,
ask on his
the
behalf?
counterfactual here is that land reverts to its original state of nature. And basically, that's what you take as the basic value to calculate the carbon opportunity cost. So with basically the land as it was with no human intervention. And David asks, is this a proper counterfactual? If adopted on a global basis, it would lead to an extremely high carbon opportunity cost of land. And one additional argument to his question is that typically those values are from pre-industrial times when population densities were completely different and global population was different. So you had to feed less numbers of people. So should we actually be adjusting that carbon opportunity cost to reflect a current state?
So actually, technically speaking, what this is the amount of carbon you can save by avoiding producing food on additional land. But it does use that. But this is the key point of the analogy I made with the oil or natural gas or the driving of cars. Yeah, if we didn't produce large cars, people would consume small cars. But if we want to know the emissions of driving a large car, you don't compare them to driving a small car. You say, what are the actual emissions of producing a large car? So to make policy, we start by saying, what is the actual cost of this human activity versus no human activity? It's the same thing. We don't compare it to the alternative human activity. We don't know what the alternative human activity would be, but we want to know this. Then we can also compare the cost of that alternative human activity. And then we can say, what is the policy should be in shifting from one to another. So the short answer is that the only way to do this calculation right is to estimate the effect of using land relative to not using land, just like it's the effect of burning coal versus not burning anything. And then after you've made that calculation, then you can compare different human activities and their costs. And if you don't do that, if you basically base your estimate of the emissions of one human activity on avoiding another human activity, you'll end up that when you add them all up, you have no emissions at all. Like driving half cars, large cars, half small cars. If you base the emissions of each on the avoided emissions of the other, you'll end up just concluding that driving causes no emissions at all. So that's a point that I think it's very strange. For land, everyone agrees with that. No one thinks you should estimate the emissions of burning coal by comparing it, by saying it's only, half, because the alternative would be burning natural gas. But for land, for some reason or other, people have got the idea that you should compare one human use of land versus another human use of land to estimate the cost. No. What's the cost of using it versus no human activity? That's the only way to get it right.
Tim, thanks a lot first of all, for all the great work that you're doing, but also for your ability to explain and break down complicated concepts in very simple terms. For those that remain in the room, can we give him a round of applause? Thank you very much, Tim.
Thank you. I'm so sorry I couldn't be there.
No, it's all right. Next time, hopefully you